This is College Algebra, Chapter 1, Section 2, Introduction to Relations and Functions. Here's two types of notation that we need to get used to using. The first is called set builder notation. It looks like this. Notice we have the braces, those are the squiggly things on the outside. You have an X and then a vertical line, and then it says X is greater than -2. How you read this is the set of all X such that X is greater than -2. We also have what's called interval notation, and it looks something like this. Got a parenthesis with a -2, a comma, and an infinity. This means the exact same thing as the previous set builder notation. It's the set of all numbers that are greater than -2. The set goes from -2 to infinity. Now, notice something. You've got a parenthesis there. The parenthesis indicates that the number that's next to it is not included in the set. This was not a greater than or equal to -2, just a greater than. You always use a parenthesis next to the positive or negative infinity symbol because infinity is not a number and you cannot have something that actually equals infinity. Also note that a bracket is used, that's the squared off parenthesis, next to a number when the number is included in the interval, when you have a greater than or equal to or a less than or equal to. And you never put a bracket next to positive or negative infinity. Okay, this chart is found in your text, and these are just some examples of the interval notation and the set builder notation. Open intervals are intervals that you have the parentheses on both sides of the notation. You can see some examples there. We have X such that X is greater than A. That means from A to infinity. The second one, X such that A is less than X, which is less than B. That means X is between A and B, and so forth. You can kind of read it and then see how that looks on the graph. Notice we're graphing things a little differently. Previously, when you graph things on a number line, you used an open circle to indicate that the number was not included and a closed circle to indicate that it was. Now we're going to use parentheses and brackets, so it's going to match our notation. Okay, take a moment to look through these. Pause if you need to. Okay, this is the rest of the chart. The first thing we have is a closed interval. Closed intervals are when both parts, both ends, are included in the answer. You're using brackets. Around both of them, you have equal to symbols under both inequalities. A disjoint interval would be when you have two intervals that are going away from each other instead of towards each other. So here we have X is less than A or X is greater than B. The reason for the or is that you can't be in both of those conditions at the same time. But when you put those two together, your answer is contained somewhere in there. And then all real numbers is really the entire number line, and there's two ways to note that. Using set builder notation, you have X such that X is a real number. In interval notation, it goes from -infinity to positive infinity. Okay, a relation is a set of ordered pairs. If we denote the ordered pairs of a relation by xy, then the set of all x values is called the domain, and the set of all y values is called the range. And this should be very familiar. Here's an example. We have a relation that consists of the points 1, 2, -2, 5, and 3, -1. The domain is 1, -2, 3, and the range is 2, 5, and -1. And you see a graph there showing those 3 points. Okay, a graph of a line or curve in the xy plane represents a relation. So let F represent a relation consisting of all ordered pairs having the form x, 2x, where x is a real number. In other words, whatever number you use for x, your y value is going to be 2 times that. Here's a chart showing those values. So when x is -2, y has to be -4. When x is 1, y is -2, and so forth. And graphically, this is what we see. And when we connect those points, we have our line. Here's another way to illustrate a relation. You can use a diagram. With the diagram, we have two ovals. The left oval contains the domain, -2, 1, and 3. The right-hand oval contains the range, 5, 2, and -1, and the arrows show which numbers belong together. So we have the -2, 5 as one point, 1, 2 is another point, and 3, -1 is a third point. You notice at the top it gives the name of the function, which is f. Okay, in this example, you're going to give the domain and range of the relation from the graph. So pause the recording, try the problem, and then resume the recording to check your answer. You should have gotten that the domain goes from -3 to 3, including both of those numbers. I know it may not look like it when you try to graph an oval with a graphing utility. Sometimes that part where it's almost straight up and down doesn't come out, but it is from -3 to 3, and the range is from -6 to 6. Notice the interval notation. You have the brackets indicating that the points are included. Here's another example. Determine the domain and the range from the graph. Pause the recording, try the problem, and then resume the recording to check your answer. The domain for this is -infinity to infinity, because the more x's you pick, it's just going to keep going on and on and on. It's not going to end. And the range goes from -3 to infinity. And again, this graph is slightly off, so if you didn't include the -3, I could completely understand that. I think it's just a little bit of an error with the drawing there. So what is a function? Well, a function is a relation in which each element in the domain corresponds to exactly one element in the range. If x represents any element in the domain, then x is called the independent variable. And y, representing any element in the range, would be called the dependent variable. For example, you're going to indicate whether this is a function, and you're going to give the domain and range. Pause the recording, try the problem, and resume the recording to check your answer. Okay, your domain is 1, 3, 5, 7, 9. Your range is 2, 4, 6, 8, 10. And this is indeed a function because each x value goes to exactly one y value. Let's try again. Determine if this is a function, give the domain and range. Pause the recording and resume to check your answer. The domain is 1 and 2, and your range is 1, 2, 3, 4. This is not going to be a function because the x value 1 has 3 y values, 1, 2, and 3. Cannot be a function because of this. Let's look at another problem like this. You're going to tell whether this is a function, you're going to give the domain, and you're going to give the range. Pause the recording, try the problem, and resume to check your answer. Okay, your domain is -4, -3, -2, -1, 0, and 1. Your range is 2. Every element in the domain corresponds to the same element in the range. Now, this actually is a function. You can have various x values all going to the same y value. You just can't have one x value going to multiple y values. So this is actually acceptable. Another example. Is this a function, and what is the domain and range? Pause the recording, resume to check your answer. Okay, the domain and the range are both going to be the set of all real numbers. No limit on what you can choose here. And every x you put in is going to give you only one y value. So, again, this is a function. You may remember we have this thing called the vertical line test for functions, and it says that if every vertical line intersects a graph in no more than one point, then the graph is the graph of a function. So it's kind of a visual way of testing the graph. So, are each of these functions? Pause the recording if you need to, and then resume to check your answer. right, the first graph, parabola, is indeed a function. Any line you draw through there is going to intersect the graph only one time, so it's fine. The circle, on the other hand, is not a function. You'll notice the line drawn there hits the circle in two spots, as will many lines drawn through this graph. Okay, the definition of a function. Now you're thinking, well, we've already defined it. Well, yes, but this is an alternative definition. A function is a correspondence in which each element x from a set called the domain is paired with one and only one element y from a set called the range. You can use a table to represent a function. In fact, that's what an XY chart is. Pick a value for x and then calculate the y based on those values. Your calculator will actually set up a table for you when you use it to graph any function, any curve or line. Okay, a word about notation. To emphasize that y is a function of x or that y depends on x, we commonly write y equals f and then the x in parentheses. And how that reads is f of x. So y equals f of x, not f times x. Note that f is the name of the function while x is the independent variable. So when I write f of x equals 3x minus 5, what that's telling you is that to get the y values, you take the x values, multiply by 3, and subtract 5. And then if I tell you to find f of 2, then you need to replace the x with the number 2 and solve. So it looks something like this. F of 2 is 3 times 2 minus 5, which is 6 minus 5, which is 1. So f of 2 is 1. In other words, function f, when x is 2, the value of that function is 1. Okay, here's another example. We're going to find f of 3 in each of these. Pause the recording, solve the problem, and then resume the recording to check your answer. The first one, simply place 3 in place of x, and 3 times 3 is 9, minus 7 is 2. For part B, find 3 in the x row, and look down at the f of x value, which is negative 9. Okay, here's some classwork problems. Pause the recording to give each of these a try, and then resume the recording to check your answer. Some more problems. Pause the recording to try them. Resume the recording to check your answer.